Welcome back. Today we're going to look at law of cosines, right? So we talked about law of sines, and now we want to talk about what happens if law of sines doesn't work. We can use something called law of cosines. So when would the law of sines fail? Well, law of sines, you have to have at least a side and an angle, but what if you just had three sides or just three angles? You could use law of cosines, okay? So law of cosines looks a little more complicated, but given your triangle, like your ABC triangle, where the sides across for them are the little letter, then we can say that a squared equals b squared plus c squared minus 2bc cosine of a. So what is that saying? Well, this side goes with this angle. So if it's a squared, you're going to have cosine of a over here. And notice it's just the sum of the other two minus 2 times the other two. So you could actually do this with any of the sides. So this one's with a squared. What if I started it with b squared? Well, if it was b squared, then the other two would be a squared plus c squared minus 2ac, and now it's cosine of b. And so then the last option could be c squared, where c squared equals a squared plus b squared minus 2ab cosine of c. All right? And so you need to know that. I don't know that you need to memorize all three. You just need to know what goes together. And so your book says, instead of memorizing each of the three formulas, it is more convenient to remember the following statement, which just puts it into words. The square of the length of any side is equal to the sum of the squares of the lengths of the other two sides minus twice the product of the lengths of the other two sides and the cosine of the angle between them. And I promise once you do this a few times, it's not so bad. Okay, so let's just start with one. What if you had a problem like this? And again, not drawn to scale, just so we can look at it. On this one, they give me all the side lengths. So 24, B is 16, and C is 29. You can solve for any one of the angles using our formula. So let's just use the first one, right? So a squared equals b squared plus c squared minus 2bc cosine of angle A. And so what we're going to do is we're going to plug everything in and do a bunch of algebra. So I'm going to get 24 squared equals 16 squared plus 29 squared minus 2 times 16 times 29 times the cosine of A. And this is where you just have to do some math. One thing I will say is remember that these three things are multiplied by cosine, so they're stuck with that cosine there. So don't get a little crazy on me, all right? So I'm going to just go ahead and do 24 squared, which is 576. And over here, 16 squared is 256 plus 29 squared is 841. And then 2 times 16 times 29 is 928 times the cosine of A. And then I'm just going to move these over, right? Like I'm just going to subtract 256 and subtract 841 to the other side. So minus 256 minus 841. And that gives me negative 521 equals negative 928 cosine of A. And that's multiplication, so I'm going to divide by that. And the negatives cancel out, it kind of doesn't matter there. But just like with sine, when you solve for that, right, I get the cosine of A equals 521 over 928. And I'm going to do the inverse cosine of 521 divided by 928, right? And that gives me 55.8 degrees. So we don't have to worry about quadrant 2 like we do with sine, because cosine is only positive in quadrant 1 and quadrant 4. You can't have an angle in quadrant 4. But you do have to be really careful when you go back and solve for the other ones now. So we still need to find angle B and angle C. And if you really love law of cosines and you want to do law of cosines again, you can. But to me, law of sines is way simpler. So here's my advice. When you go back, always solve for the shorter side that's left. So we solve for angle A. The other angles that we need are angle B and angle C. So I'm going to solve for angle B next because it's across from 16. Because if it's an obtuse angle, The obtuse angle will always be across the biggest side, and we'll talk about that more in class. But so always solve for the smallest side next, okay? So I'm going to write that here. Smallest side. Smallest angle. So I'm going to switch back to law of sines. So I'm going to say the sine of b over 16 equals, what? Sine of 55.8 degrees over 24. And again, you can do this all at once on your calculator, or you can do it and then do inverse sine. I'll show my steps here. So sine of 55.8 divided by 24 times 16 gives me 0.551387. And then I'm going to do inverse sine of 0.551387 to get that angle B equals 33.5 degrees. And so I have angle A, I have angle B, and now I can solve for angle C by just subtracting from 180. Minus 33.5 minus 55.8, and I get 90.7. If you tried to solve for angle C first, you would not get the right answer. So I cannot stress enough that if you go back to law of sines, you have to solve for the smallest side first. Okay? So let's look at one more. What about on this one? So if you notice, I always draw my triangles the same. On this one, they tell me that side A is 15, side C is 42, and angle B is 49. Notice also that we couldn't do law of sines here because I don't have a side and an angle. But what I can do is if I have an angle and not the side across from it, I can solve for that using the law of cosines. So now I'm solving for B. So using B squared, it equals the other two sides squared, so that's 15 squared plus 42 squared minus 2 times the other 2 times the cosine of 49 degrees. Now this one is way less work than the last one because all we're trying to do is solve for B right now, which means honestly you could do this all at once on your calculator, right? Because to get rid of the square, we're just going to square root it. And so this is what I type on my calculator all at once, the square root of 15 squared plus 42 squared minus 2 times 15 times 42 times the cosine of 49. And that's going to give me what B equals. So now I got to type that in. Square root of 15 squared plus 42 squared minus 2 times 15 times 42 times the cosine of 49. And that gives me 34.1 as the side length. So now I need to find angle A and angle C. And again, if you want to do law of cosines, you can. But once you find one thing, you now have enough information that you could go back to law of sines. And again, same rule as before. Which angle should I solve for first, angle A or angle C? Hopefully you said angle A because it's across from the smaller side. So that way, if it's obtuse, then it's going to have to be across from the bigger side. So that's why we do that. So I'm going to say sine of A over 15 equals sine of 49 over 34.1. And I'm just going to do this all at once on my calculator. So I'm going to do inverse sine of sine of 49 divided by 34.1 times 15. And I get that angle A is 19.4 degrees, which makes sense because it's the smallest side, should be a smaller angle. And then now to find angle C, I'm just going to take 180 minus 49 minus 19.4. And again, the only way I'm going to get that obtuse angle is if I solve for the smallest side first. Okay? And I think that's, oh yeah, that's it. Okay? There's some of these in your exploration if you really want to work on it.